Our objective for today, I can solve and graph quadratic equations. Read together, 1, 2, 3. I can solve and graph quadratic equations. So last week we started with quadratic functions, and I wrote / equations because it's we're looking at it through the scope of highest degree 2. And today I'm just going to focus on quadratic equations. And that's where we do need a fair amount just to make sure that we are certain as to what we're looking at. Quadratic equations, what are they? They are two variable equations where the highest degree is 2. Examples: x squared plus 3x plus 2 equals y, x squared minus 9 equals y, y minus 6 equals 3x squared minus 11x. Copy that, please. All right, let's see. According to the definition, simple, straightforward definition, it says two variable equations. Is this an equation? Yes. Two variables? Yes. Equation? Yes. Two variables? Yes. Equation? Yes. Two variables? Yes. Highest degree 2. Is the highest degree 2 on this one? Yes. This one? Yes. And this one? Yes. Pretty straightforward, right? Now we understand what we're looking at. Non-examples. Copy these. X squared plus 3x plus 2, and negative 3 plus x equals 10. As you're copying, they'll start thinking these are not quadratic equations because, bless you. All right, tell your neighbor why those are not quadratic equations. All right, volunteer. Who's got this? Jerry. Okay, close. Jaden? Only one variable, not an equation. Only one variable, not an equation. That is correct. How about this last one? Degree is not 2, and what is it missing also? 2 variables. That is correct. All right, so write some hashtags, everyone. At least 3. What makes a quadratic equation a quadratic equation? Hashtag what? Alexander. 2 variables. What else? Hashtag Leslie Art. Highest degree 2. Highest degree 2. One last one, Maria. Equations. That is correct. I'll add one more. Hashtag bam, because we've arrived to quadratic equations. Let's go. Yeah? We good? It was like anticipation, right? That anticipation to the anyways, never mind. All right, steps. Underneath that, write steps. And we'll write those at the end. I want to make sure I get through a process and you understand exactly each step. By now, this point of the school year, you should be able to come up with your own steps, right? And we've been working on that, yeah? Even though, yeah, I kind of like walk you through, but pretty much you should be understanding each step of the process, all right? Now, what's the point of that? The point of that is that when you're not here anymore, I have given you the tools to be in any math class where you can actually look at an example, repeat it again, and think about what would be the process to follow. Does that make sense? All right, so with that said, turn the page over. We will need probably half a page or a full page per problem, so make some room. You do need colored pens and pencils if you have those, so have those handy. Copy example number 1. And it says, example number 1, solve the quadratic equation by factoring and check your answer. Equation given, x squared plus 8 equals y plus 6x. Copy that, and then I'll go over the process. So, it says, example 1, solve the quadratic equation by factoring. Last week we started by graphing. This week we start by factoring. Step number 1. Even though it seems like I only did one thing, I did 2 main ideas here at the beginning. 2 things need to be true in order for me to begin solving. And I just did both of them in one. Talk it over to your neighbor, see if you remember what are the 2 things that need to be done. All right, let's see. Chris, get us started. What do I need to have done? What is one thing?
You need to isolate the y.
Isolate the y, or I'm going to call that solve for y. And you're not copying this, you're just paying attention. One main idea, yes, leave y by itself. What is the second main idea that needs to be true before I begin solving? And if you solve the second thing. Stephanie, go. I haven't got to the next step, but I'm saying, what is true about this? Roman, what order? What is that called? Standard form. That is correct. So you see, a lot of things that you've done before, now it's all coming together in one. You need to, your noodle already has them there, we just need to go through the process. So does everybody understand both things? Isolate the y, and needs to be in standard form. Because I could have written negative 6x plus x squared plus 8. Was that in standard form? No, therefore standard form. Okay? That was step 1. Let me go to step 2. Check this out. For step 2, before I do step 2, I want you guys to understand what we did last week. Here it goes. Last week, we graphed parabolas. Is that cricket? There. And they look something like this. And I said the solution is here. But I gave you guys an essential question to write down and to answer. Was that, you guys remember that? So the question was, the solution to what is a solution to a quadratic function? Tell your neighbor, what is a solution to the quadratic function? On 3, everyone. 1, 2, 3. That is correct. The x-intercepts. And that's why I even highlighted them in red. You guys remember that? And then from there I wrote solutions. And then I wrote 2 parentheses, right? For example, what if this was negative 2 and this was positive 2? What would be one of the solutions? Negative 2, 0. And the other one? Positive 2, 0. What do you guys notice about the y? The y is what? On both, right? And this is what? My solutions. Therefore, check this out. Now that we established that, look up. In order for me to begin to solve this equation, which means to get my x-intercepts, what needs to be true? The y needs to be what? That is correct. Make y equal to 0. So therefore, x squared minus 6x plus 8. Everybody Following now? Okay. Does everybody understand why it becomes 0? Because at the end, for the intercepts, y is 0. All right. Step 3, focus please. Here it goes. This entire process here. Tell your neighbor what it's called. What is that called? One word on 3. 1, 2, 3. That's correct. Factor. Are we there so far? Okay. So, next step. Writing utensils down. Look up. Here we go. Step 4. The next step, I'm going to give you the name of the property that we're going to use. Zero product property. And this was, I mentioned this at the beginning of the school year. This was introduced in elementary, and I just mentioned it briefly. I said, who remembers when they told you that any number times 0 equals? And I said, we're going to see that later on. We're not going to use it as much, but that's the property. Now we're going to use it. Everybody ready? Here we go. This is how zero product property works. Let's say I have the number A, and I multiply times 0. What does that equal to? What if I have 0 times the letter B? What does that equal to? But what if I have A times B equal to 0? Question. What could A be? What could B be? This is what we call the zero product property. Now check this out. What if I told you that the zero product property is here? Look at it. Do you guys see it? This times this equal to 0. Therefore, what would I write next? X minus 2 equal to 0. X minus 4 equal to 0, because A could be 0 or B could be 0. Does that make sense? All right? That's the zero product property. From here on, instead of me saying the whole thing because it's too long, I'm just going to say Z, P, P. Everybody see that? You down with Z, P, P? Yeah, you know. Anyways, however, look at what I have left. Look at this and look at this. What does your noodle want to do here and here? Talk it over to your neighbor. What does your noodle want to do, guys? We can't combine like terms. It's an equation. What can we do here? Solve for x. Let's see. Plus 2 plus 2. X equals 2 plus 4 plus 4. X equals 4. These are my solutions. X intercepts, zeros, also known as roots. These are all 4 names that we're going to be using, that you're going to be hearing about. Copy that, please. We're halfway there. What's that? Yes, the process. Copy the process and the steps over here. Yeah. If you want to copy them on the side of the way I have them, that's fine, or put them in the front once you're done copying the process. I'll give you guys some time. And the zero product property, this one, you don't need to write it down, but that's only if you want to keep it for your own notes. That's okay. I'm going to erase it in a little bit, but I'll leave it up there for right now. Copy that, please. So. All right, really quick. Let's elaborate on the labels of the solutions. Does everybody understand why they're called solutions? Because that's what we get, x equal to. That's going to solve the equation, right? We solve the equation, there it is. Does everybody understand why they're called x-intercepts? Yes, because yesterday when we graphed the last week when we graphed the quadratic function, we established that the x-intercepts were the solution. Does everyone understand why they're called zeros? Because when the quadratic function or the parabola crosses the x-axis at the x-intercepts, what is the value of y? 0. Okay. However, let's elaborate on roots. Hold on, give me a second. So, really quick, I'm going to elaborate on roots. Remember when you watched the lesson, right, over the weekend? And I was elaborating on using the area model, yes? Then I talked about, for example, 12 times 12. What is 12 times 12? 144, right? But it could also be written as 10 plus 2 times 10 plus 2. And it becomes an area model, right? However, what is the total area? So if I was to put this here and this here, what are the dimensions of this 10 plus 2 and 10 plus 2, which is 12 times 12, right? How do I get that? So let's see, if the area is 144, how do I get that? By taking what? Doesn't that give me 12 times 12? That's why they're known as... No. I'm just elaborating so you understand why the name is being used. All right? All right, so here we go. Stephanie, they need you in the office. You're going home. Bye. I don't know. All right, here we go. Step number 6. Writing utensils down. Pay attention. Here we go. Ready? All right. Graph. Here we go. Look up to the screen. Ready? All right. To graph, I need to use the intercepts. Okay? So with that said, look up. Looking at this equation, the one that's in y form, look at it. If I was to ask you to identify the y-intercept, tell your neighbor what you would tell, or what you would say the y-intercept is. On 3, everyone. That is correct. You see how everything's now like, your noodles already there? That is correct. 8. Because it's the constant in the equation. What are our x-intercepts? 2 and 4. 2, 4. From left to right for me to graph this. Copy that, please. All right, so that was step 6. Let's go to step 7. Number 7. What do you think 7 would be?
Check.
That is correct. Check. So watch. To check, I'm going to use the y-form equation. So I'm going to write x squared minus 6x plus 8 equals y. X squared minus 6x plus 8 equals y. Tell your neighbor why I wrote it twice. Everyone? There's 2 solutions. 2 and 4. And we need to check both of them. So I'm going to substitute the first one into the first one. So what is x? 2. So it's 2 squared minus 6 times 2 plus 8 equals, however, look up really quick. If the solution is 2, what is, excuse me, what is the value of y? That is correct. So therefore this is 4 minus 12 plus 8 equals 0. So what is 4 plus 8? Minus 12. Let me do the second one. 4 squared minus 6 times 4 plus 8. And once again, what is y? So this is 16 minus 24 plus 8 equals 0. What is 16 plus 8?
24.
Minus 24.
Yeah.
And that's how you check. There you go. All right, we're done with example 1. Oh, you know, like, what? All right, example number 2. If this fit in half of your page, you only need the other half with the next example. If it didn't fit, if you fit more than half a page, then you need another page. Example 2, write this down. I'll leave mine up there, but write this new equation down. Example 2, y minus 7x. Once again, example 2 is y minus 7x equals x squared plus 10. I want you to solve it, graph it, and check it. Ready, go. Try and see if you can do it without looking at the process. Unless you get stuck, then look up to the process. I left example number 1 up there for you to as a reference. Ready, go. Once again, example 2 is y minus 7x equals x squared plus 10. Go. Let's see, get us started, please. Leslie C. What needs to be true on step 1 in order for us to get started? Solve for y, and it has to be in standard form. So solving for y, I need to leave y by itself, so plus 7x plus 7x. That leaves y by itself, but then it needs to be in standard form, so I need to write x squared plus 7x plus 10. Hands if you got that. Okay? Since we need to solve, what is the second thing that we need to have in step 2, Paulina? That's step 3. Hold on, you got it. Y equals 0. That is true. 0 equals x squared plus 7x plus 10. And as Paulina mentioned, step 3 is factoring. We got 10, 7, that's 2, and 5. Yes? So this is x squared plus 2x plus 5x plus 10 equal to 0. Group. We got x plus 2, 5, x plus 2 equal to 0. So 0 equals x plus 2, x plus 5. Step 4. What do we do from there? Leslie R. ZPP, yeah, you know me, that is correct. X plus 2 equals 0. X plus 5 equals to 0. So step 1, 2, 3, 4. Step 5, everyone. Solve for x minus 2 minus 2. X equals negative 2 minus 5 minus 5. X equals negative 5. These are my solutions because of obvious reasons. X-intercepts, because when we graph them, they are the x-intercepts. Zeros, everyone, why are they zeros? because when the solution has y equal to what? 0. And my roots, and I showed you that earlier. Okay, let's graph this. Let's see, -2, -5, and my y-intercept is, everyone? 10, from left to right. Hands if you got that, and you know how to check, yes? Okay. Go to the next one, number 4, example number 4. You can do the check later on by yourself. If you're not done, that's okay. Copy this one, example 4. F of x equals x minus 4 times x plus 2. Doesn't that look weird, f of x? What shall we change it to? Y equals x minus 7, x plus 2. Now that it's y, what do we change it next to? 0 equals x minus 7, x plus 2. Question, didn't they do all the work already for us? Yeah. What did you do from there? Leslie R. You done with ZPP? Yeah, you know me. X minus 7 equals 0. X plus 2 equals 0. And then we solve for x plus 7 plus 7. X equals 7 minus 2 minus 2. X equals -2. These are my solutions. X-intercepts, zeros, roots. All right, let me graph this. And the more we practice, it becomes easier, right? -2, +7. But there's a dilemma here. Look up really quick. Look up, look up, look up. We need a y-intercept, don't we? So look up. What are the roots here? And what is the y-intercept? What is the roots? And what is my intercept? So tell your neighbor the y-intercept for this one. -14. From left to right. Bam. Our home plate for tonight is on page 577, but I only want you to do numbers 19 to 22 graphed. I want you to do all of them, but the only ones that I want graphed are 19 to 22. You don't have to check them. Tell your neighbor what I just said. Okay? Reminder, there is tutoring. If I don't see you guys tomorrow. Bye.